Hello, everyone. We're going to be working through discussion week 4, titled How Much Money? So question 1, in this problem, we're going to be trying to figure out how much money the account has given the conditions stated. In other words, how much money is Fry drooling over? After watching the video, we can make the following conclusions. Fry's starting amount or principal is going to be 93 cents. The interest rate is 2.25% or 0.0225. The time is going to be over 1,000 years. So we know that P equals 0.93, R equals 0.0225, and T equals 1,000. Knowing the information that we do, we can use the simple compound interest formula. So that's going to be A equals P times 1 plus R raised to the T power. So if we plug in the numbers that we know, we get A equals 0.93 times 1 plus 0.0225 raised to the 1,000th power. So from here, we just solve for A. So entering this into your calculator, you're going to get the answer that Fry is drooling over $4,283,508,450. In the video, the teller is going to round up and tell Fry he has $4.3 billion. That's what I did for questions 2 and 3, just to make the math a little bit easier. Dealing with these high numbers, the rounding is not as big of a deal. So that's going to bring us on to question 2. Suppose we wanted to make the same amount as Fry, but in a much shorter span of time. So let's say that you plan on retiring in 30 years, and you would like to have a final balance equal to what Fry has in his bank account. Assuming that you can earn an interest rate of 15% per year, compounded monthly, how much would you need to put in? So this is going to be a little bit different because now, rather than just an annual rate, we're going to be compounding monthly. So we're throwing in an extra step in here. So using that, or knowing that, the new formula that we're going to use is going to be the amount equals the principal times 1 plus rate divided by your number of compounding units raised to the number of compounding units times time. So plugging in the numbers that we do know, the amount that we want to end up with is going to be 4.3 billion. We don't know P, so that's just going to leave it there. P times 1 plus 0.15, because our interest rate is 15%, divided by 12, which is the amount of compounding units, raised to the 12th times 30. 12 being our compounding units, 30 being the amount of time in years. So to solve this formula, I started to simplify on the right side of the equation. So first you want to calculate 1 plus 0.15 divided by 12, which is going to give you 1.0125, and then you're also going to multiply your exponents. So you're going to get 12 times 30, which is going to leave you with 4.3 billion equals P times 1.0125 to the power of 360. Next, what we're going to do is take 1.0125 and raise that to the 360th power. So that's going to give you 4.3 billion equals P times 87.54. Continue to simplify by dividing both sides of the equation by 87.54. So you're going to have 4.3 billion divided by 87.54, and that's going to equal P. Once you do that, you'll find that P equals $49,120,402.10. So your starting principal would need to be $49,120,402.10 to be equal to what Fry has after only 30 years. Now, question 3 definitely gave me the hardest time out of the questions. This one takes a little bit more thought because we're solving for an exponent. So question 3 is going to be, finally consider the situation in which you invest what you currently have in your bank account. For fun, let's suppose that amount is $1,000. If you could earn 15% per year compounded monthly, how long would it take you to earn as much as Fry? So once again, we're dealing with a monthly compound rate. So basically, we're solving for the unknown exponent. So what we're going to plug in is 4.3 billion equals 1,000 times 1 plus 0.15 divided by 12 raised to the 12t power. So first we're going to simplify the equation by dividing both sides by 1,000 and then solving inside the parentheses. So when you divide 4.3 billion by 1,000, that's going to give you 4.3 million. And then when you're dividing 0.15 by 12, it's going to give you 1.0125. So final equation is going to look like that. 4.3 million equals 4.3 million equals 1.0125 raised to the 12th power times t. So now we need to use the natural logarithm to bring the exponents down and then simplify the equation using our calculators. So looking like this, so it's going to be natural log of 4.3 million equals natural log of 1.0125, bringing the exponents down times 12t. So when you put the natural log into your calculators, you're going to be left with 15.27 equals 12t times 0.0124. Further simplifying that by multiplying 12 and 0.0124 brings you down to 15.27 equals 0.1488t. Finish off by dividing 15.27 by 1.488t, and that's going to leave you with t equals 102.62. So roughly 102 and a half years, between 102 and 103 years is what it'll take you to earn about as much as what Fry had. If I plug that number into the original equation on our calculator, it leaves you with a final amount of about 4.4 billion, so it's fairly accurate.